Hi, class 12. So, by this class, we're gonna finish our first chapter. Okay, so shall we start next chapter or what? By today, we'll start next chapter. No. Okay, so tomorrow we'll start next chapter. Okay, so let's finish the last application. That is your third application of Gauss's law, isn't it? As of now, we done two application of Gauss law. So this is your last. Okay, so write down third. Okay, so the electric field produced by uniformly charged thin spherical cell. Okay, cell. Okay, so cell means not like a sphere. Okay, solid. It's not a solid, it's a cell. Okay, hollow. Okay, inside there is air. Okay, so like your TT ball, you know TT ball. If you see this TT ball, then if you cut this TT ball, you'll get the air inside, isn't it? So that is your hollow ball. Okay, so first step, what to do? Identify the charge. Okay, so here you have surface charge density. Okay, don't confuse with this. Okay, surface charge density, so don't go with volume. Okay, so this is your, let's make a, so this is our hollow cell. Okay, like a ball. Okay, but inside there is cavity. So this is your r, is your radius of the cell. Okay, and we are putting charge, isn't it? Distribution of charge is your surface charge density. Okay, volume भन्नु हैन नि फेरि, surface हो. Okay, here we have three case. Okay, outside the cell. Okay, this is the point. On the cell, this is also a point. Okay, and inside the cell, so this is also point. So three cases are there, isn't it? So if I take this as r, then this is r equals to r, and this is your r which is less than r. Okay, so let's declare the uh, declaration. Okay, so let us consider uniformly charged thin spherical cell of radius r, capital letter R. Okay, you know this, you already identified this charge, isn't it? Let sigma be the surface charge density. Clear up to here? Clear? It's not a solid, it's a hollow. Okay, भित्र के छ cavity. So first case, let's start with first case. So this is your first case. Oh, this is your first case, second case, and this is third case. Okay, so case 1, so where r is greater than r, isn't it? This r is greater than this r, capital letter R. In book you may see that outside this cell. So next step, what to find? Gaussian surface. You have to find the Gaussian surface. Okay, so this is our Gaussian surface. Okay, ठुलो ड्रा गर्नु, मेरोमा एरिया अलिक कम्ती भएछ. Okay, this is our Gaussian surface. Okay, imagination. Okay, so write down. Now we imagine a Gaussian surface of radius R, this R. Okay, so the flux, so first main formula, isn't it? The flux through this is your del S, then this is the del S, and this is E, isn't it? So flux through del S is what, you know, isn't it? Small flux equals to E, the small area cos 0 degree. Why? In same direction, isn't it? So net flux, so net flux is how much? Summation of this one, isn't it? Summation of this equals to summation of E del S cos 0 is your 1. Okay, लेख्दा भयो नलेख्दा पनि हुन्छ ल. So this sum, if you sum is if you add all the small flux, you'll get the net flux. So this is E, and del S is your surface area, isn't it? So we know that this surface area is your bigger Gaussian surface. Okay, so E equals to, sorry, E 4 pi r square. So radius, S is your surface area of Gaussian surface. Okay, त्यस कारणले गर्दा के भयो, r, नभए के आउँथ्यो, नभए क्यापिटल R आउँथ्यो हैन. So this is your 1. So next, by Gauss law, so write down again by Gauss law, again by Gauss's law. So what you flux equals to how much? Q enclosed by epsilon naught, isn't it? Yes, this is your Gauss law. So phi equals to how much? Phi equals to, you have sigma 4 pi r square. Why? Because surface charge density is your sigma, S is your surface, then charge equals to how much? Sigma S, but S over here is your 4 pi r square. See this one, surface area of this sphere. Okay, so now this is your second. Okay, now equate or from one end to what you'll get, E 4 pi r square equals to sigma 4, sorry, divided by epsilon naught is there, isn't it? 4 pi r square by how much? Epsilon naught. So or this becomes how much? E equals to sigma 4 pi r square divided by epsilon naught 4 pi r square. What is this? This is your Q, isn't it? Q equals to this much, isn't it? So you can write this as E equals to Q by 4 pi epsilon naught r square. So direction, next direction is your normal, or you can say normal or radial. Okay, along this one, along this one, isn't it? Radius of the Gaussian surface. Clear? So this is our first case, right? So second case, write down case 2, that is your when r equals to capital R. This is the case. Okay, second case. So again find, you will get same step. Okay, follow same step, you will get. So E equals to, only this will change. Okay, यहाँसम्म पुग्छ. Okay, तिमीहरु, then this will change. So sigma 4 pi r will change, isn't it? R becomes r divided by epsilon naught, or 4 pi epsilon naught r square. Why? Because see, this is r, okay, and this is also r, isn't it? Capital R on the surface or on the boundary of cell. So these are gone, 4 pi also gone. Left E equals to sigma by epsilon naught. Now this is vector quantity, okay, so vector, so normal, isn't it, n cap. So third case number 3, when r is less than r. Now listen, this case is very important, okay. See, this is your again Gaussian surface you have to take, isn't it? Here see how much charge is there, 0, okay. So by first main formula, phi equals to how much, E 4 pi r square. But from Gauss's law, what you will get? You will get Q is equal to Q enclosed by epsilon naught, isn't it? See how much charge is there enclosed, 0, isn't it? Charge त यता छ, isn't it? यहाँ छ, boundary मा छ charge. So center मा कति charge? How much charge is there? 0. So this becomes 0, this becomes 0, so whole quantity becomes 0. So phi equals to 0. This is your 2, okay. Now equate this 2, so E 4 pi r square equals to 0. So E equals to 0. बराबर देछ, यो 0 भने यो पनि 0 हुन्छ, isn't it? So this what ends your chapter, okay. And for your entrance, let me do some extra, okay. So if I plot the distance, that is your r, isn't it, and electric field of hollow cell, then what I'll get at the center, what, 0 0 0. So at r equals to r, it will increase, okay. So by how much? By sigma by epsilon naught times, okay, clear. Then again if you see this side, that is your r greater than r, okay. So that time this will again decrease. So this is the graph, okay. So this point is your sigma by epsilon naught, and these are the E equals to 1 by r square, clear. Why? Because r is greater than this one, is it, this case, r square, okay. R is greater than small, big, capital R. So that means this is greater than this, clear. So hope you understood the chapter, okay. So मजाले हेर, मजाले डिराइभ गर, पज गर भिडियो, ओके. त्यहाँदेखि के गर, आफै कोसिस गर्ने गर, तीनटै आफै गर्ने गर, त्यहाँदेखि मात्रै हुन्छ राम्रो. सो यो अलिक निट बनाऊ ल, तिम्रो अलिक गसियन सर्फेस सेकेन्ड केसमा यही हुन्छ ल. सो अलिक सफा बनाऊ, यो अलिक ठुलो बनाऊ, गसियन सर्फेस मजाले बनाऊ, ओके. So that's ends your chapter number 1. So by tomorrow we'll start new chapter, okay. So be ready.